Hello students, this is Coach Holliday, and in this lesson we're going to be looking at graphing linear functions. And so go ahead and take out your notes packet if you have it. If not, then just do this on notebook paper, and let's go ahead and get started. Alright, first of all, let's talk about what a linear function is. A linear function is just simply a function whose graph is a line. Linear has the word line in it, okay? So let's keep that in mind, and we're going to do some work with the linear functions here in just a minute. What I have here, I do have a linear function for you, and it's f of x equals 2x plus 3. Remember, this is f of x means y, okay? So I've given you some domain values, -5, -4, -1, 0, 1, 3. And what we're going to do is we're going to use those domain values and the function, and we're going to find the range, graph the order pairs, or list the order pairs, graph this, and such from there, okay? So the way we find these range values is if I take that x value, the domain value, and I put it in place of x. I'm going to do that for each of these domain values, and there's 6 of them. So if I take -5 and put it in for x, 2 times -5 is -10, plus 3 would be -7. Alright, -4 times 2 is -8, plus 3 would be -5. -1 times 2 is -2, plus 3 is +1. 0 times 2 is 0, plus 3 is 3. 1 times 2 is 2, plus 3 is 5. And then 3 times 2 is 6, plus 3 is 9. And remember, we're always going to write these in our set brackets, and that's your range. Now we want to go ahead and list the order pairs, so you'll take every x value and put the y value that goes with it. Alright, so I'm going to go ahead and list these: -5, -7, -4, -5, -1, 1, 0, 3, 1, 5, and the last one is 3, 9. Alright, so there are the ordered pairs in our relation. Okay, now what we're going to do is we're going to graph each of these ordered pairs. So -5, -7, 1, 2, 3, 4, 5, 1, 2, 3, 4, 5, 6, 7. -4, -5. -1, 1. 0, 3. 1, 5. 3, 9. Alright, so I've got all these points graphed. And now what I'm going to do, if I look at those points, it looks like they make a line. And what I could do, I just pick these domain values, but I could pick -3, -2, I could pick 2, I could pick -20, I could pick -4.5. If I start plotting these points, they'll all end up being on this line. Alright, they'll all be being on the same line. So what I'm going to do is I'm going to go ahead and draw a line through these points to show that it represents that. So if you notice, I went ahead and drew that line, and now what we're going to do is we're going to list the domain and range of the line. Remember, the domain has to do with the x-axis. We're going to set boundaries, but notice it goes forever to the left. So the left boundary for the domain is -infinity. Remember, less than x is less than, and it goes forever to the right. There's no boundary there, so we'd say +infinity. Alright, the better way to say this though is it's the set of all real numbers. Alright, so it's going to be all real numbers. The range is the same thing. It goes forever down and forever up, so we're going to say that's also the set of all real numbers. This is the best way to write it when you write the domain and range of a line. Okay, now here's a couple of comments or a couple of sentences we're going to complete from a unit or two ago. The first one, we're going to talk about the vertical line test. If you remember, the vertical line test is a test that you can perform on a graph to determine if the graph represents a function. And a graph represents a function if all vertical lines drawn through the graph intersect the graph at only one point. Alright, so that should be a quick review for you on vertical line test. If I look back at the previous graph and I do the vertical line test across, notice that this line, it doesn't touch any vertical line in more than one place at a time, so it would be considered a function. Okay? Alright, now let's go on to example number 2. In example 2, we're going to use the function g of x equals 1/2 x plus 2. We're going to do the same thing we did in the last example. So take a moment, put the video on pause, plug those domain values into the function, find the range values, list the order pairs, and graph those points. Okay? So go ahead and take a moment to do that. When you finish, go ahead and start the video back up. Okay, so I've listed the range, -2, 0, 2, 3, 5, 6, based on those domain values. And the order pairs are listed there also. I then took the order pairs and I graphed those points. And if you'll notice, they all pretty much make a line. So I'm going to go ahead and draw a line through these points. So there's your line. And now we want to look at the domain and the range. Now notice this thing goes forever to the left, goes forever to the left, and it goes forever to the right. So our domain is going to be negative infinity is less than x is less than positive infinity, or we could just say all real numbers. And the range, it goes forever up. I'm sorry, it goes forever down. I'm going to look bottom to top first. It goes forever up, so it's going to be all real numbers also. And again, you could have listed it as negative infinity is less than y is less than positive infinity, but just to write it with all real numbers is the very best way to do that. Okay? Alright, now we're going to use this information. We're going to go back and answer some more questions that are on your paper. And the first question asks, which is the dependent variable in the graph above? Remember, the dependent variable is always our y-axis. It's always our y-axis. So the dependent variable is going to be the y. Would the graph pass the vertical line test? Well, if I look at it, if I drew vertical lines, all the way up and down the graph, I just drew a bunch of vertical lines, and I kept doing that, notice it's only going to touch my graph at one point at any one time. Okay, a vertical line will. So it does pass the vertical line test. So I put a yes there. Will all linear graphs pass the vertical line test? That's a good question. If I go back, and we've already talked about this in class before, if I draw a vertical line on my graph, and then I did the vertical line test, when I did the vertical line test, every point on that line would touch that vertical line. So no, that would not pass the vertical line test. So all linear graphs will not pass the vertical line test. Specifically, vertical lines will not pass the vertical line test. Okay? Will a line ever have a domain which is not the set of real numbers? That's a good question. If I look at my graph, all right, and it's asking about domain, let's look at this line right here that I just drew. That line from there to there. The domain is actually every point on this line. I'm sorry, let's go back. Every point on this line has the same x value. Every point has the same x value, which is 5. So therefore, or what, 1, 2, 3, 4, 5, yeah, 5. So therefore, every x is 5. The domain for this is only 5 if I just use this vertical line. So will a line ever have a domain that is not the set of real numbers? That would be true, and it would be a vertical line. A vertical line will not have a domain that is all real numbers. Will a line ever have a range that's not a set of real numbers? And yes, if I draw a horizontal line on my graph, every point on that line will have the same range value. In this case, it's 1, 2, 3, 4, 5, 6. Every point on this line has 6 as the y, so therefore the only range value would be 6, and that's a horizontal line. So that would be, will a line ever have a range value which is not the set of all real numbers? And that would be yes, a horizontal line. So those are some things that we've already talked about in class that you should already have an idea about, that we're just going back over and looking at them, okay? All right, make sure that you complete your WISC. Bring any questions you have to class, and we'll get those answered for you, and include those in the WISC at the end of the WISC. We'll see you in class. You can get yourself an A, you can have a good